slope of linear equations. Let's define slope to get started. So slope is a ratio. Remember, a ratio is usually a fraction. So some value in the numerator, some value in the denominator. It is the ratio or fraction of vertical change vertical change, that's the rise over the horizontal change. And we call that the run. Okay, so slope is, we use the letter M for slope, rise over run. Okay, where if the fraction is positive, it tells us that we're going up over the run, which is going in that direction. And if it's negative, then we're going to go down, and then we're going to run in that, and then we are going to run in that direction. Notice when we run, we always go that way. Think about this for a minute. If this is my graph, if I'm rising, if I have a positive slope, I'm going to go up and run, and then I'm going to go up and run, and my line is heading upward. And if it's a negative slope, I'm going to go down and run, and then I'm going to go down and run, and so now I have a negative slope. So the positive or negative goes with the numerator to tell us whether or not we're going up or whether or not we're going down. But the denominator, the run, is always left to right because that's the way we read. Okay, I want you to just be very careful about that. All right, so let's look at this example. Find any 2 points on the line that can be used to find the slope, and then identify the ordered pairs of the 2 points and then calculate the rise over run. So if I just gave you these and I said, hey, what do you think the slope of this line is? I would expect that you would look at it really carefully and you would say, okay, I think this point right here is crossing right on the x-axis. And then, oh, I don't know, I'm going to go up a little bit. And I think I'm going to go and look at maybe this point, and I think it is perfectly crossing at the x. So you just kind of eyeball where you think it's crossing perfectly, and then you calculate between those 2 points what you think the slope is. So up 1, 2, 3. So I went up 3, and I went over 1, 2, 3, 4, 5. So the slope would be rise 3 and run 5. And these are just estimates. I mean, these are really hard. They're shadows, so it's kind of hard to tell. We're just trying to get a little idea of how we would find slope. Same thing here. So I'm going to look for points where I think they're crossing perfectly. I'm going to choose this one, and then I'm going to choose this one. Now this slope is going down, so it's going down 1, 2, 3. So down 3, and then over 1, 2, 3, 4. So this one has a slope of -3/4. This one looks like it's crossing at the origin, and then again at every single other point. So I'll just choose this one. It's going up 1, 2, 3, and over 1, 2, 3. So this one has a slope of rise 3 over run 3, or you could just simplify that right down to 1 over 1. It doesn't matter. And that's how you find the slope given 2 lines on a graph. Okay, if you're just kind of eyeballing it. Now, that's just using the graph. Now let's use the formula to find the slope. So we do need to refresh our memory as to what the slope formula is. Some of you might remember it. We've said it so many times in the past. I'm sure you probably remember that slope, we use M to mean slope, y2 minus y1 over x2 minus x1. Okay, so again, when you look at these points, this is my first point, so this is x-coordinate first point, y-coordinate first point, the x-coordinate of my second point, and the y-coordinate of my second point. That's where the x1, y1, x2, y2 come from. And then we go y2 minus y1, -2 minus -1. That's where everyone makes the mistake, subtracting a negative. Be really careful. 3x2 minus x1. So 3 minus negative 5. So remember, y is on top, x is on the bottom. It's upside down. Second one minus the first one. So everything's backwards. Start at the back, work your way to the front, y is on the top, x is on the bottom. When you are subtracting a negative, that is the same thing as adding. Okay, so we end up getting negative 1 over 8. Negative 1 over 8. Okay, and then you can test it if you're not sure. Here's the point, negative 5, negative 1. And here's the point 1, 2, over 3 and down 2. So you could test this, down 1 and over 1, 2, 3, 4, 5, 6, 7, 8. Down 1 over 8. So we did okay. Down 1 over 8. Let's check the second one. Y2 minus y1. 3 minus negative 1, or 3 plus 1. And then 5 minus 2, which is 3. 3 plus 1 is 4. So I get 4/3. Again, if I were you, I would just go ahead and double check it. So over 2, down 1, here's my first point. And then over 5 and up 1, 2, 3. So here's the point 5, 3. And now I'm going to test. I should go up 4 and over 3. 1, 2, 3, 4. Go up 4 and over 1, 2, 3. So I did go up 4 over 3. Again, this was a negative slope going down. This one's a positive slope going up. Let's see what this last one is. Y2 minus y1. So 7 minus 1 over x2 minus x1. 5 minus 3. 7 minus 1 is 6. 5 minus 3 is 2. And 6 divided by 2 is 3, or 3 over 1, meaning I'm rising 3 and I'm running 1. Let's check it. Over 3 up 1. And over 5 up 1, 2, 3, 4, 5, 6, 7. Okay, so those are my 2 points. I should be rising 3 and running 1. 1, 2, 3, run 1. 1, 2, 3, run 1. So that works. I had to do it twice in order to get from the first point to the second point, but I am still rising 3 and running 1. Rising 3 and running 1. So that seemed to work just fine. All right, so that's calculating slope given the picture or given the 2 points on the line, and you had to actually use the formula. Now let's talk about the 4 kinds of slope. We often get these very mixed up. I think the first 2 are perfect, and you're going to have no problem with them whatsoever. And those are both positive and negative. So positive slope, I know you guys are very good at this. Okay. Positive slope is when the line is going up. Okay, so traveling up from left to right. So as I'm reading on my page from left to right, as I'm going across the page, my line is going up. Okay? So that's an example of a positive slope. What do they look like? When you're looking at slope, it could say 1/3. That's positive. So going up 1, running 3. It could say 5 over 2. That's still positive, so it's still going up and over 2. Or it could just be a whole number. It could be 7, because remember, you can rewrite 7 to say 7 over 1. So still rising 7 and running 1. So these are all examples of what positive slope looks like numerically. Okay, let's talk about negative slope. So here's your Cartesian coordinate plane again. So negative slope is when your line is headed downward. So now it's traveling down from left to right. Again, from left to right. As you're going across your page, your line is going down. So examples of what negative slope must look like. It could be negative 1/3 it could say, the negative could be up here with the 1 written that way. Or it could say negative 4/3. Please make sure that you remember when it is written this way that that negative goes with the numerator. That's how you tell whether it rises or falls, and that the bottom is always running left to right. Always, always. Just be really, really careful that you don't confuse those, okay? Zero slope. Again, this doesn't seem to be the one that really gets us confused. And a zero slope is a line that neither rises or falls. It is a flat line. It's not rising, it's not falling, it's just a flat line. It has a slope of 0, okay? So imagine when you're looking at an equation of a line and you have a slope of 0, and the 0 times the x is going to make the x go away. So any equation that is just y equals some number is an example of when your slope is 0. Okay, y equals some number. There's no x term. So equations that have no x term, they are flat lines or zero slopes. The last example is the one that always seems to get us, right? But if you just think about all your others, positive, negative, or no slope, then undefined or zero slope, then an undefined slope should make sense to you. That is when the line is rising and falling at the same time. There is just no way to put a value on that. It's rising and falling at the same time, which means the slope is what we call undefined. Okay, so in this case, you're going to calculate slope. Remember, y2 minus y1 over x2 minus x1. You're going to get a slope in the numerator and some number, or 0 in the numerator, sorry, and some number in the denominator. But over here, you're going to get some number in the numerator and you're going to get 0 in the denominator. We cannot divide by 0. That is an undefined slope. There's no way to put a value on a line that is both rising and falling at the same time. Okay, there's just no way to do it. And so this equation has a positive mx plus b. This one has a negative mx plus b. This one has a 0x plus b. And this one just has an x equals some number. There's no rest of the equation. X is -2. You draw a vertical line at -2. There's no other way to describe that line.